everybody. Welcome back to another AWS On Air segment at the Paris Summit 2023. I am Jordan Sullivan. I'm a developer advocate for Amazon Bracket, and I'm here with my co-host. Adrian, would you like to introduce yourself?
Sure. Hi, everyone. My name is Adrian San Miguel. I'm a principal in the Special Partner Engagements Group inside of AWS and the partner organization. Happy to be here.
Wonderful. And we are here today with Ipo, who is a distinguished engineer in Redshift. So what are you going to tell us about today?
Hi, Jordan. Hi, Adrian. So my name is Hippocrates. I'm a VP Distinguished Engineer with AWS. I have been at AWS for the past 7.5 years.
Wow.
And today I'm going to talk about analytics, how you can analyze the vast amounts of data our customers store at AWS. And in particular, I'm going to talk about the evolution of our cloud data warehouse service, which is called Amazon Redshift.
Sweet. Well, I know I have wondered what Redshift is for at least 2 years, so now is my time to finally learn. So I would love to hear you tell us all about it. I think you've got a slideshow yet?
Yeah, sure. Redshift is a cloud data warehouse. Sure. Okay. Let's bring some slides also up. Actually, let me then go from the basics, from the beginning.
Awesome.
It's
exactly what I need.
Cloud data warehouse that allows you to, in a very secure and reliably way, to analyze your data. You bring in data, you drop them in, usually on Amazon S3 or an operational database. You do your transactions and whatnot, and then you can use this data to add some intelligence in your business. Redshift is a cloud service. It has been in production for the past 10 years. And as of last year, as of last summer, we are now also offering a serverless version of this service, and we're excited about it.
Sweet. Can't wait to see what's next. The suspense of the next slide.
Okay. We have been in production for almost over a decade now. Actually, in fact, we launched the service exactly a decade ago, and we have tens of thousands of customers using Redshift to process every day several exabytes of data. It's a very, very big service. At the core of it, we have kind of some pillars. At the core of it is we offer a very scalable, secure, and reliable service to analyze your data. And we make it, on the one side, very easy to ingest data, put data into this system to analyze. And on the other side, we offer very flexible ways for you to analyze your data in terms of what SQL constructs you can use, as well as whether you would like to use Spark or SQL to use the data, or whether you want to use machine learning to analyze your data. A very powerful surface for you, the customers, to go and come and analyze your data. And we do that with primary focus being, in addition to the security and reliability, being on the performance, how fast and how scalable this thing is. We have been, we have a very large team, and we are looking into the performance and scalability of Redshift. And we can tell you with confidence that we are kind of leading the pack there. In this slide, which is the one we used back at reInvent of last year, 2022, we went out and we compared Redshift with other very popular cloud data warehouses. And we can say with confidence that we offer, at least in these benchmarks, between 10% and 5 times better price performance than competition. The other thing that, I'm sorry, Adrian, please.
No worries. It's actually pretty salient to where I was going to go with this. These are fantastic benchmark numbers. These are fantastic reductions in query and out-of-the-box price performance. And I think you mentioned something on the previous slide, something about being able to do that with familiar SQL. So you mean the average developer, the average operator isn't going to have to go learn a new language. They can just continue on with the SQL they've always written?
Yes, and one thing that we see over the recent years is that uh, uh, customers are coming and they don't have highly structured tabular data that was kind of the bread and butter of data warehouses. They come in with data that may not have very strong schema. And this is an area where we have been expanding the capabilities of Redshift. For example, we have introduced a new data type, which we call super. We are very good at AWS in naming things, so we called it super. And this allows customers to bring data in without schema and run schemaless queries over that. So for example, you may have a super column that you put, you have a JSON record that has the customer order, and then you can go and say select customer.order. Something, and so this is a very, very flexible way to run queries even on semi-structured data.
Wow, that's like super cool. That you can do schemaless queries. That is super useful.
Yeah, I guess I can call myself a DBA at this point.
Yeah.
Horrible. Yeah, that's actually pretty exciting.
Yeah, related to that, what we have seen is that over the recent year, we have been in production for a decade now, right? What we have seen over the recent years has been a movement or a change in what our customers are using Redshift to do. And we have seen a shift towards, let's call them operational analytics or streaming analytics, or they have vast amounts of logs or click streams or something like that. And they would like to use a system like Redshift to analyze data that, for example, there are like log records, and that's why they need this super column to go and do their analysis. But they also need very low response times and at the very high throughput, which is kind of not what databases or at least warehouses have been designed for in the decades before now. So this is another area where we have put in a lot of our energy. And what we see, again, when we compare with competition, is that Redshift offers the highest throughput per, normalized to the amount of data, the price customers are paying, as well as auto-scaling capabilities to meet these needs of low latency, high throughput workloads that have low latency requirements, which is something that, it's a shift we have seen is for our customers, is that they're going towards more operational workloads.
Gotcha. So could you give me actually an example of the type of short query that customers are kind of now a little bit more interested in?
Yeah. So for example, traditionally database warehouses were used to load the data of the transaction records of the day. At the end of the day, go and bulk load them into the warehouse and then run some reports that a few people were able to do. Now you have this continuous trickling load on your operational systems, or or your pipelines, your streams, where you are doing stuff that are very important for your business. And then on the consumption side, it's not only the report that would say, okay, this is the ledger for the day or for the month, but it would be me and you going to the bank and running, doing something and wanted to see a small report of how we are doing or things like that. So this is kind of the workload that it is for the masses, and you have thousands of concurrent users that may be hitting the system at the same, which again was not the kind of the sweet spot for at least the databases of the past, of the yesteryear. And this is an area where Redshift has, we have been spending a lot of our energy again we're working on to make it very efficient to load data from fast moving sources. So as of last December, with G8, capability of Redshift to ingest directly from streams. So you can have data in a Kinesis stream or a managed Kafka stream and have the data in very low latency be loaded into Redshift. So again, we launched last year a capability of Redshift to stream data into Redshift. You can have your data in Kinesis as well as managed Kafka streams, and the data there you put them in the stream and they appear with very low latency into the warehouse for you to run analytics. Similarly, we have the capability, which we are now in preview and we're going to launch very soon, where we continuously monitor. You register a bucket in S3, and you keep on dropping files into this bucket, and the system automatically auto-loads this data into the warehouse.
Oh, that's super useful.
Yes.
Yeah.
The third area, which again we're trying to innovate in the ways to make it very easy to move data from the operational stores to the warehouse for the analytics store, has been what we announced at reInvent last year when we called it Zero ETL. What we did in essence was we worked very closely with our state-of-the-art and best-of-class operational data system database that we have, which is Aurora. And we did an integration at the storage layer of Aurora and Redshift, and we make it very easy without creating ETL pipelines to keep on reading and writing data into the database, into Aurora, and the data appear almost like magically into the warehouse for you to go and run your analytics.
Where was
So
this?
again,
Where was this in 2017 when I had to put together a 14 different piece complicated ETL pipeline to do a 100 petabyte ingestion? This would have saved
exactly.
so much time, money, and effort, frustration.
Money and effort, yes. And the brittleness of that, right? Because now we kind of make this a managed thing. We make it an our problem. So you can see that there is a theme of the things we are working on, that we try to make it very easy for our customers to load data with low latency into the system, to make them available for analytics.
Mm-hmm.
Yeah, it's really
hand,
cool when you can kind of see the evolution of a service from essentially something that's like, well, there's only one type of person that can actually do these sort of database queries, and it can only happen like once a day, and kind of just bringing it all the way to right now and just like completely democratizing it and being like, well, I mean, your data doesn't have to be in any particular format. Like, you don't have to do this like manual ETL process, and you can just actually get it directly from your data sources. It's really, really cool to see that evolution.
Yes, and towards this, what you just said, democratizing analytics, we are also excited for Amazon Redshift Serverless, which is something with G8 we launched this summer in July. We have already thousands of users that use Redshift Serverless. We take a lot of the decisions or administrator actions that normally would be a responsibility of somebody, a database administrator, that would also normally cost a lot of money to have. And we make it a problem of the service, and we try to offer the best of class capabilities in this front. And we make it very easy for customers to go up, spin up a serverless endpoint, and start running analytics. And we are also excited about the new features. We keep on making it easier for customers to use Redshift Serverless. And we have a bunch of new capabilities that we announced over the past weeks. For example, as of a few weeks ago, we announced that we have lower capacity configurations for Redshift Serverless. It just costs now at $2.88 per hour to have an Amazon Redshift serverless endpoint with 8 RPUs. That is Redshift processing unit, so the unit of what you are buying with Redshift serverless. And we price at the second granularity. That means that with a few cents, you can run very, very powerful analytics in vast amount of data. At the same time, we are making it easier to go and run queries in the lake. So now, whenever you spin up a Redshift serverless endpoint, you Jordan, you go to your console, you spin up a Redshift serverless, we automatically mount your Glue catalog, where you maybe have indexed all your data in open file formats in S3, and you can start running analytics on your data in S3 using Redshift serverless, using the very advanced query processing techniques that Redshift offers. And similarly, because we want to make it very, very easy to load data into Redshift, we just announced now the ability to go to the query editor, to our console, and go and have a file in, say, in a CSV file in your laptop, and immediately load this data into Redshift without having to go through the intermediaries of having to upload them to S3 and then copy them into the system. So again, as you can see, there is another theme in what we are doing is we're trying to make very easy and democratize analytics, making very easy for you to run these types of things.
Great. Thank you so much for that, Ipo. So something that you had mentioned a little bit ago, that Redshift just turned 10, and it looks like you've really been at the center of quite a few significant changes in Redshift for the past few years, as we continue talking about how data warehousing itself has evolved over time, customers' needs, and how they're really looking for new approaches, new strategies, and new ideas and how to get things going. Would you mind talking to us about how Redshift is proactively taking those customer needs into account?
Yeah, I mean, it has been a very interesting ride the past 8 years I have been here. But one thing that we do like to say at AWS, we listen to the customer. We try to understand the needs, and we drive the innovation towards filling their needs. So when we launched the service, there was, customers did not even know what running data warehousing in the cloud meant, and that was a big revelation when we launched the Redshift 10 years ago. Then when they came back and they told us we really like the performance of the system, we really like the usability, but we would like to put more data and we would like to have more users running it. And then we went and separated compute and storage. I offered auto-scaling capabilities. Then they told us, oh, we would like to, consume data from more than one source of data, not only the data I load in Redshift, but we have open file formats in S3, we have data in operational systems, in Dynamo, in Streams. Then we went and built the capabilities to go and be able to consume, analyze data from all these sources. Then they told us, so we really like that, but still it requires some tuning from us to do it. Then we went and built a lot of machine learning. We used machine learning as a tool to make all this automate and be smarter in all these mundane administrator decisions that previously were responsibilities of database administrators to do.
And actually, I'd love to hear a little bit more about that. What types of machine learning algorithms are you using, and what are some specific tasks that you actually are automating away?
Yes. So there are some things that Redshift, like any warehouse, there are a bunch of decisions that you need to take. For example, when you are loading data, you may want to vacuum them, sort them in a way so that it is more efficient for processing when you're consuming the data. You may decide to change the physical schema of the database, like what kind of distribution algorithm you're going to use, which keys you're going to use to distribute the data or sort the data. You may even decide to go and create materialized views. Materialized views is a construct that pre-computes some frequently consumed queries. All these decisions are decisions that we are using in Redshift. We are making that an our problem. We use machine learning algorithms, we monitor the usage of the system, and we make decisions when we have confidence that if we do something like that, a change in the either in the physical schema of the database or on run some maintenance operations such as analyzing to update the statistics or running a vacuum operation or something like that, so that we improve the performance of the system. So we make the system faster without you, the customer, being involved. We kind of auto-tuning capabilities into the system. And given all these years of experience we have gathered running Redshift for 10 years now, and the scale we are operating, these things become smarter and smarter.
And it looks like at this point, all the customer has to do is just go build on top of Redshift. Is that right?
Yes, sir.
That's awesome. Thank you so much, Chipo. Did you have anything else that you kind of wanted to leave on, or did you want to walk us through this beautiful architecture diagram?
Yeah. So what kind of where we're going with that is we have been building a very, very good core data analytics technology in Redshift. And with the introduction of Redshift serverless and the ability to share data across Redshift clusters and consuming data from open file formats in S3, we enable our customers to go and build data mesh architectures and create architectures that are very scalable. So that is kind of on the core of the system. In this picture, I kind of have it at the center of the picture where you can go and create a data mesh with provision Redshift clusters, serverless endpoints, and what have you. Then, on the left-hand side, we make it very easy to ingest data into the system through either auto-copy from S3 or streaming ingestion or operational databases, or even by using Amazon Data Exchange service, because you can go and get some data from some vendors and put them in valuable data there. And then on the other side, we are trying to be very innovative in the ways you are consuming the data, either by using machine learning, algorithms, or even Spark, or very, very strong SQL processing capabilities. So this is the picture we see. How we see our customers. We should evolve their architectures to, and we are very excited for the future. As we like to say at Amazon, it is still day one. And we are just, asking our customers to go and build, as Adrian said.
Fantastic. All right. Thank you so much again, Ipo. This was very fascinating. And in fact, I did learn what Redshift is over the course of this presentation. So, A+.
All right.
All righty. Have
you.
a great time at the Paris Summit, everybody. And cheers. See you next time.
See you. Thank you.
See ya.